Hello friends, welcome you all in our basic electrical engineering course. In that first unit is DC circuits. These are the unit contents as we are seen in the first lecture of the video. In this lecture, we are going to study the series circuit. In last lecture, we already studied Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law. In this lecture, we are going to study the series circuit and what is the total resistance of the series circuit or equation of the total resistance of the series circuit. First, we will see the definition of the series circuit. A series circuit is the circuit in which the circuit elements are connected end to end and remaining two ends are connected to the power supply. The circuit elements or the components are connected end to end. Components or circuit elements are same. These components are connected end to end and remaining two ends are connected to the power supply. The circuit is known as series circuit. Here we see the actual series circuit consisting of three resistances. A and B are the ending points. See, the resistance R1, R2 and R3 are connected in series. That is, the resistance R1 having 2 points. One is starting point and another one is ending point. Similarly, R2 and R3 has also 2 points, starting point and ending points. The circuit elements are connected end to end means what? The ending point of the first resistance is connected to the starting point of the second resistance. Means end to end connection. Similarly, the ending point of the second resistance is connected to the starting point of the third resistance. And remaining two ends are connected to the power supply means what? The starting point of the resistance 1 R1 that is point A and the ending point of the resistance R3 that is point B. These 2 points are connected to the power supply or voltage source or battery, it can be said that. Here we are saying that A and B are connected to the power supply. Current flowing through the series circuit is I and it will be the same for all resistances R1, R2 and R3 because the circuit is series circuit. Voltage across R1 resistance is VR1, voltage across R2 resistor is VR2 and voltage across R3 resistor is VR3. This is the total circuit diagram. Are you getting? Three resistors are connected in series, that is R1, R2, R3 and remaining 2 points, that is ending points, are connected to the power supply, that is voltage source V. Okay. Next, see, in the above circuit, when the voltage V is applied between point A and B, current I is flows in the circuit. At voltage V is applied to the circuit, at that time current will start to flowing in the circuit. Because of current I, it will produces the voltages VR1 across resistance R1, VR2 across resistance R2, VR3 across resistance R3 respectively. Let capital R be the equivalent resistance of the circuit and we have to find the equation of this equivalent resistance or total resistance. First, we apply Ohm's law to the above circuit. We will get the equation V is equal to I into R. Here V is the total voltage of the circuit, I is the total current of the circuit and R is the equivalent resistance or total resistance of the circuit. Similarly, we can apply this Ohm's law at each element of the circuit, that is R1, R2 and R3. At R1, we will get the equation VR1 is equal to I into R1, VR2 is equal to I into R2 and VR3 is equal to I into R3. These three equations are getting from the Ohm's law. Okay. Next, we can apply Kirchhoff's voltage law. We know the Kirchhoff's voltage law already studied in the last lecture. What is the statement of Kirchhoff's voltage law? In any closed network or circuit, the summation of EMF in that closed loop is equal to the summation of voltage drop in that closed path or loop or circuit. That is, we will get the equation V is equal to summation of VR1 plus VR2 plus VR3. We are having the value of VR1, VR2, VR3 and V also. Put these values in above equation. That is V is equal to VR1 plus VR2 plus VR3. We will get the next equation V is equal to VR1. Instead of VR1, we are here putting I into R1, VR2 I into R2 and VR3 I into R3 and V is equal to I into R. The equation will be IR is equal to I into R1 plus I into R2 plus I into R3. Take I common. I into R is equal to I in bracket R1 plus R2 plus R3. I will get cancel and we will get the total resistance R is equal to R1 plus R2 plus R3. This is the equation for calculation of total resistance or equivalent resistance of the series circuit. Finally, we conclude that the total resistance of the series circuit is equal to the summation of the individual resistances. That is, R is equal to R1 plus R2 plus R3. Here we can write the conclusion also. Thus, in series circuit, it can be seen that or it can be observed that the equivalent resistance of the series circuit is equal to the summation of the individual resistances. Also, in series circuit, current flowing through each element is same, but the voltage across them will be different. Okay, these two conclusions are found in series circuit. Are you getting? The total resistance of the series circuit is nothing but sum of the individual resistance. That is R is equal to R1 plus R2 plus R3. And current flowing through the series circuit is same, but the voltage across each element is different. Okay, this is the total derivation of series circuit. In next lecture, we will see the parallel circuit or parallel combinations. If we found this information is useful, please do share with your friends and don't forget to subscribe our channel. Thank you.